So you saw how a channel can be used to wait for the completion of a Go routine. Now you can also use a channel to wait for the completion of multiple Go routines. For that, we want to make sure that the channel is created before we run these Go routines, of course. And we then should make sure that all these Go routines accept such a channel. So in this case, this second parameter should be accepted by the greet function as well. And of course, that function then also should write data to that channel. It should send data through that channel once it's done. Now we can pass this done channel to all these Go routines, so to all these functions. And that is really important to understand. You can use one and the same channel with multiple Go routines. That is absolutely fine because this channel, as mentioned before, is in the end a transmission device, a communication device, and it is capable, and indeed intended to be used, to receive multiple values, not just a single value. You can use it for that, but you can also send multiple values from different Go routines through the same channel, as I'm doing it here. However, if you save and run this code, you'll get some strange results. If you run this a couple of times, you'll eventually get different outputs. Sometimes just the last message maybe, sometimes the last message and another message. So we don't have a consistent behavior here, and we definitely don't wait for all Go routines to finish. Instead, it looks like we have some kind of race condition here, where the function that completes first simply ends the execution of the program. And indeed that is what's happening here, because we're using one and the same channel for multiple Go routines, and we then simply read from that channel here, in this place, at the end of the main function, which to go simply means that we're done as soon as we got one value out of this channel. Now we could read 4 times here. If we do that and we run this, the result will be different. Now we indeed wait for that long taking task as well, and we then output all these results. Please note that we're not outputting them in the order we have here, but instead in the order in which they finished. So that is one thing to keep in mind with channels. If you use the same channel for multiple Go routines, you also have to wait for as many values as you have Go routines, at least if you want all of them to be finished. Now, of course, since this code here is not very scalable and we always have to update the number of reads from this channel whenever we add another Go routines, since that's not ideal, there is an alternative way of handling this. We can work with a slice, which we can also create with the make function, where the slice should contain a bunch of channels. Because a channel is just a normal value, so it can also be stored in structs, slices, maps, wherever you need it. And then here we can create such a slice of channels with 4 empty elements, for example, here for this application, since I know that I will have 4 Go routines. And then instead of using that one channel, we can simply add new channels for every Go routine, again by using the make function. And then we want a channel that transports a boolean, and we store that as a first element in dones. And we then use this first element, so this first channel, as a channel for the first Go routine. And then we can repeat that, and we could of course also handle this with some kind of for loop here, but here I'll simply do it by hand like that, and create all these different channels which are stored in these different positions in that dones slice here, until we populated all 4 empty elements that were created initially, and we passed those different channels to the different Go routines. And now we can use a for loop down here to go through the different done channels that we have in that dones slice with a for range loop, and we then simply read all these channels. And with that, we'll then wait for as many channels as we have here. Therefore, if you run that, we get the same result as before, and we wait for all operations to finish. Now, since managing such a slice of channels can be a bit cumbersome, Go also gives you another feature you can use, instead of creating multiple channels and managing them in such a slice. Therefore, I'll comment out all that code and instead use another approach. And for that, I'll bring back that single done channel and pass that single done channel to all Goroutines again. So we're back to one channel for all Goroutines. But now, to make sure that we don't have to manually add as many reads from done as we have Goroutines, as we had it before, we'll use a different feature built into Go. We can also use the for loop directly on a channel, with the range keyword still, but now instead of passing a slice or a map after range, we pass our channel as a value after range. And that is a feature that is supported by Go. And then inside of this for loop here, we'll actually not get the channel, but instead, as you see, the values that are emitted by that channel. So a bunch of booleans here, actually, which we could now output here with println. Now, if we do that and we use this for range loop directly on this one single channel that is used for all these different Goroutines, if we do this and run this, you now see we again wait for all operations to finish, but at the end it looks like we have a problem here, that all Goroutines are asleep. In addition, we also print true all the time, of course. Now we can get rid of that true value by simply not caring about the value returned by the done channel. And in the end, if we don't need the value, we can also get rid of it entirely like this and write the for loop like that to go through all the done values nonetheless. So with that, we would still get that output and wait for all invocations, but we would also get that error at the end here. And we get this error because, of course, now Go doesn't know when this channel is out of values. We simply loop through all the values and we wait for new values to be emitted, but eventually there will be no value left, and that's why we're getting an error. We can work around this problem by explicitly closing the channel once we're done, with help of the close function to which you pass the channel that should be closed. And I'm doing that in that slow operation here because I know that here we don't need that channel anymore once this operation is done. This, of course, however, therefore only works if you do know which operation will take the longest and after which operation this channel isn't needed anymore. Because if you close a channel with the built-in close function, it, of course, as you might guess, can't be used to send any data anymore. But with that, we explicitly tell Go when that channel is done and therefore when it can stop waiting for new values. So therefore with that, we now get the same output as before, these messages, and we got the message from the long running task, but then the program exits without an error. But as mentioned, this only makes sense if you do know which operation will take the longest.